Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the critical points for the function, determine where the critical point is a local maximum or minimum, sketch the graph of each function. So we have to find the critical points for this given function. Critical points are points at which the derivative of a function is equal to 0 or undefined. So the first step is to find the derivative of this function. Now this function is a polynomial function. So prime of f at x equals, so we have to find the derivative of the three terms in this function. So for the first term, negative 2x squared, we can use the power rule. So negative 2 is the coefficient, so it will stay as it is. And as per the power rule, the derivative of x squared is 2x. And then exponent 2 minus 1. So we move the exponent to the front and then we subtract 1 from the exponent. Now in the second term, the 8 is the coefficient, so it will stay as it is, and the derivative of x is 1. And 13 is a constant, so its derivative is equal to 0. Now we can simplify this expression, so prime of f at x equals, so we get negative 4, so negative 2 times 2 is negative 4, and then x. Now the exponent of x is 1, but we don't write 1 as an exponent, and then plus 8 times 1, which is 8. Now there is no x value that will make the prime of f at x undefined. So we just have to find the x values that will make the prime of f at x equal to 0. So we'll sub in 0 on the left side. So we get 0 equals negative 4x plus 8. And now we can isolate x in this equation. So we should add 4x to both sides. So the 4x on the right side will cancel each other out. So we get 4x equals 8. And now we can isolate x by dividing both sides by 4. So the 4's on the left side will cancel each other out and we get x equals 2. So this is a critical number for this function. So this function has just one critical number, and now we can find the critical point by subbing in x in the given function and find the function value for x equals 2. So we get f at 2 equals negative 2 times 2 squared plus 8 times 2 plus 13. So f at 2 is equal to, so 2 squared is 4 and negative 2 times 4 is negative 8 and 8 times 2 is 16 plus 13. And f at 2 is equal to, so negative 8 plus 16 is positive 8 and 8 plus 13 is 21. So the critical point here is 221. So this function has only one critical point. Now we have to find whether the critical point is a local maximum or minimum, and for that we can use the first derivative test. So we should find whether the function is increasing or decreasing on the left and right side of this critical point. So we can use the number line method. So we'll start by drawing a number line and we can show the critical number. So x as 2. So this critical number divides the number line into two parts. So we can use a test value from each part. So on the left side of 2, we can use the test value 1. And on the right side of 2, we can use the test value 3. So we have to sub in these test values in the prime of f at x to find the sign of prime of f at x on both sides of this critical number. So if prime of f at x is less than 0, that means the function is decreasing on that side of the critical number. And if the prime of f at x is greater than 0, that means the function is increasing on that interval. So let's start with the test value 1. So prime of f at 1 is equal to negative 4 times 1 plus 8, and prime of f at 1. So negative 4 times 1 is negative 4, and negative 4 plus 8 is positive 4. So we got a positive value. That means the function is increasing on the left side of x equals 2. Now we can use the other test value, x equals 3. So prime of f at 3 equals negative 4 times 3 plus 8. So prime of f at 3 equals negative 12 plus 8. So prime of f at 3 is equal to negative 4. So the negative value means that the function is decreasing on the right side of x equals 2. So since the function is increasing on the left side of this critical number and decreasing on the right side, so we can conclude that there is a local maximum at the critical point 221. So we can write our conclusion: local maximum at the critical point 221. So we are done with the second part. Now we have to sketch the graph of this function. So for that, we'll have to find the intercepts for this function. So let's start with the x-intercept. So for x-intercept, we should sub in the function value as 0. So 0 equals negative 2x squared plus 8x plus 13. Now we cannot solve this equation using factoring, so we'll have to use the quadratic formula. So x equals, so minus b plus minus b squared minus 4ac over 2a. Now in this equation, so a is equal to negative 2, b is equal to 8, and c is equal to 13. So now we can sub in these values in the quadratic formula. So we can move to this side. So x equals, so negative 8 plus minus square root of 8 squared minus 4 times negative 2 times 13 over 2 times negative 2. So x equals negative 8 plus minus. So 8 squared is 64. And now we can multiply negative 4 times negative 2 times 13, which is equal to 104. So plus 104 over negative 4. Now we can simplify this expression. X equals negative 8 plus minus square root of 168 over negative 4. And now we can do square root of 168. So we get x equals negative 8 plus minus 12.96 over negative 4. So we get two ways the positive and the negative case. The positive case will be negative 8 plus 12.96 over negative 4, and the negative case is x equals negative 8 minus 12.6 over negative 4. Now we get, so negative 8 plus 12.96 divided by negative 4 equals negative 1.24. So this is our first x-intercept, and the second x-intercept, so negative 8 minus 12.96 and then divided by negative 4, so which is equal to positive 5.24. Now we can also find the y-intercept. So for y-intercept, we'll sub in x as 0 in the given function. So f at 0 will be equal to negative 2 times 0 square plus 8 times 0 plus 13. So the first two terms will just become equal to 0. So the y-intercept is positive 13. So the y-intercept is 0. Now we can use all of this information to sketch the function. So we can let's start with the local maximum. So the local maximum is at 221. So let's assume there is 2 here and then 21 here. So this is the local maximum, and the y-intercept is 13, so that will be somewhere here, and the x-intercepts are negative 1.24 and 5.24, so somewhere here, and then on the other side of the local maximum point, so maybe somewhere here. So this is negative 1.24 and the other one is 5.24. So on the left side of x equals 2, the function is decreasing. So the curve should be directed upwards from left to right, because the slope of the tangent to this curve should be positive. And on the right side of x equals 2, the function should be decreasing. So the curve should be sloping downward and it will pass through the x-intercept 5.24. So this should be the sketch of this function based on the analysis we did. So these are the steps you have to keep in mind to solve this type of problem. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.